Well, we've had to put that base station on one side, the CBHQ, because I'm waiting for a capacitor in the power supply. Normally we don't take them off the bench, but since DHL took over from Parcel Force for RS, we get the parcels days late, so it's an absolute nightmare. So we've got two Maxcom 4Es here. I've just pulled this out of the box. Oh, it's the first one as it happens in the letter. No transmit, no receive, public address works, S-meter lights up, channel display comes on correctly, TX light not coming on, and it's got holes in the top cover. He's enclosed the microphone, but the microphone hasn't got a plug on it. Now we only use these metal ones, which aren't cheap, but there you go. Either those 20p ones, which are dreadful, or these, or even more. So can we get the sleeve up there? So what I'm going to try and do is not have to take, I'm just going to cut that final end off just in case it's got moisture in it. Just pull out these conductors and just see what state they're in. Anyone who's been following my things, the difficulty in getting screened curly leads these days, and all the ones I've been seeing recently attached to new microphones when you buy them from like AliExpress and that, they've all turned out not to be screened leads. I don't know how they're going to perform, but I think we've used one, and I've made sure I wired up all the unused conductors as an earth. Now the joke was, with the Maxcom 20E, it had a 2-year guarantee on the radio and a 2-minute guarantee on the microphone. It's a little better than chocolate box plastic, and many a lorry driver crushed one immediately, so it is nice to see an original Maxcom microphone. Now we don't know what colour's what, but I'll tell you what, it's going to be obvious. So we've got the screen. I would think red's going to be transmit, I would think black's going to be receive, and that one with this extra screening is going to be the audio. And that's how I'm going to wire it. And I'm going to have every faith. You can see I'm just pulling these off with my fingernail. Got built-in wire strippers. I'm going to have to go and see Mr. Chippy and ask if he's got a reel of solder for me, because he seems to be in charge of reels of solder. I can't see where our list is for the microphone pinouts. Pause the video. So back to the video, and I've dug out one of the charts that's kicking around on the internet. It's showing, and you have to remember on 5-pin DIN, the pinout is 1, 2, 3, 4, 5, because when it started life as an audio connector there was only mono, and that was the left hand channel, and so you had record and playback for tape recorders between 1 and 3. When stereo came out, your right hand channels carried on 4 and 5. So we've got audio to pin 1, the braid to pin 4, transmit to pin 2, receiver to pin 5, and it says no connection here, but in fact the circuit diagram shows a link between 4 and 3. That link is diagonal. This is mirror image, but you have that link, so if you manage in that mirror image, that's where you should be. So that's how I've done this. So we'll see how, before I put the shield on, hello, testing 1 2. Well, that doesn't do anything, does it? And it's supposed to, so we'll open the mic up and see whether the wires that I thought went wherever, if they go wherever. Because you never know whether somebody's wired this differently inside or whether I'm totally mistaken. So let's have a look. Well, I've got, yeah, in fact, this isn't wired how you'd have expected. So the black ones transmit, the red ones receive. Surely that's a bizarre way to do it. I could have buzzed that through with a multimeter, but I was absolutely convinced that it would be that way round. I didn't say I could put one of these back together. However bizarre the wiring is at the mic end. At least the screened wire is going to transmit an audio to the microphone itself, in which case we would have had to rewire the mic, because sometimes they've been altered in the head. Right, so we'll swap those round at the plug end. Using our jig makes it a bit easier. Of course, you never do as neat a job next time. It's a matter of swapping over the red and the black. They're really neat in the solder buckets first time round. Not necessarily so the second time round. Testing 1 2, testing 1 2, testing 1 2. 1 2 1 2. Oh, I'm not getting anything out of the PA. Oh no, you have to switch it to PA, don't you? Testing 1 2, testing 1 2, 1 2 1 2, 1 2. I'm actually getting no audio through that, am I? Testing 1 2. So we've got the audio there. We'll open this mic up again. He's probably bought this mic in a box of junk and the reason it's in the box of junk is because it doesn't work. You know, it's all this loft find and barn find. The reason they're in barns and in lofts is because they don't work. Right, so we'll key this up again. It's very corroded, isn't it? I think it's mic stuff. So it's 500 ohms on the back, so now that's impedance, but so it's going to be somewhere near. Now the mic's open circuit. Well, I think it's so corroded that the wires are probably snapped. Having gone to all that trouble now of putting a plug on this, I'm going to have to look in at one of our boxes of junk and see if we've got a mic. But to get the set working, it's back together. Worry about that if we ever get to that point. Hello, Mr. Chippy. Mr. Chippy's spying on me. I'll pause the video. Right, so I put the offending mic back together-ish with a plug on, so we'll use this to do the repair. I've had a look in one of my sheds. I knew I'd seen a Maxon mic somewhere. I had indeed. Everything except the insert. So once again, testing 1, 2. We know that mic insert's no good. The radio is actually going into public address, so that is a useful test. So we better open it up. Don't know why that's tight. Now this whole series of sets, the Maxcoms, the Colt 295, 295A, the Midland 2001, 3001, 4001. I remember I'm talking about UK FM sets here. What else was the Comtron 40F, Cobra 19, was it? Or, no, 21XFM. They all have this same Maxcom chassis made in Korea. And although they've never had startling receive performance, they are competent sets. They do 4 watts. And he's done a nice job soldering those back on. So he's trying to get a VCO voltage. And can't, but with a lot of these sets. Wow, that's warm. Oh, it's just, I think it's just the meter resistor. Yeah. So, with a lot of these sets, where the test point is, there are actually no components. I'm not sure whether this is the case on this set. So he says he's got no transmit. He says the transmit light doesn't come on. That these are quite common to fail, so that is fair enough. So why have I got no receive suddenly? Weird. I did have till I took the lid off. Anyway, I'll put the signal generator on. I've put the signal generator on full whack and we can see there is no nothing. Where's receive gone? Let's go back in the PA jack. We've just got a dirty connector. Yeah, I think we've got a dirty connector there. Let's poke some service hole down it. These are gold plated pins. Well, that's not getting anywhere, is it? It doesn't even sound normal, to be honest. So let's see whether we've got anything. When I bought my original Maxcom 4E from Nottingham, it was Mark Smith Auto Sales, 333 to 335 Carlton Hill, Carlton, Nottingham. So who remembers Mark Smith Auto Sales? And I bought my sample in March 1982, from which I photocopied the instruction book, which has a lot of service information in it. So the idea is to connect the test instrument between the test point and ground. The test point is there. So if we locate that on the radio itself, it says test point, but in fact you have to go to something else. It's not very, it's that resistor. That resistor there. So it looks like this one, the test point's actually got parts fitted. Because they're kind of trying to get you to do it from underneath, but that's not convenient. I think these are negative earth. Yeah. The test point is there. So it's resistor 158, resistor 160 is next to it, 158 actually goes to the test point. And this is L116. Now, with it being this far out, I'm not expecting to be able to just twiddle this and it work. We could do the same by keying up. I'm not sure it's keying up. I'm not sure it's even keying up. But it's certainly got no receive. So the 8-volt regulator is that one there. So let's see between earth. So we've got 8 volts. So that's our input voltage, that's our output voltage. So we've got that. So what's happening there? That's just dirt. We could go on the phase lock loop chip. Is it pin 1 or is it pin 14? I can't remember. We've got 6.7 volts there. Pin 20, what am I talking about? Phase lock loop chip, pin 20. So we'll see whether the oscillator is running between pins 11 and 12. And get to that. So I can see that we have, there's 10.24. Is that in the video? Not sure if you can see the meter. 10.24. So the oscillator's running. Slightly low, but shouldn't stop the thing from transmitting. So we now, I'll just check with our monitor receiver that it isn't transmitting a few inches. So the synthesizer isn't running. Oh, I hope the phase lock loop chip isn't at fault. You know what, I think we ought to prove that this is actually going into transmit. And one of the bugbears is that the transmit light doesn't work. and I don't think it works. I don't think it's a matter of it's not lighting because there's a malfunction elsewhere. I genuinely think the LED has failed because they have a tendency to do that on this chassis for some reason. There's no reassurance that the thing's keying up at all. It doesn't suddenly make the phase lock loop work, but it certainly helps in my diagnosis. Oh, these are stiff. That's one. Oh, I've got really strong fingers as well. I'll turn it off and we'll just unscrew this little board that carries the LED. It'll be fun putting that back. But it looks a genuine set, it doesn't look like it's messed with. So what we're going to do, try and put the meter on the, I'll switch the radio back on, we'll try and put the meter on the connections to that. Let's put the meter in the video. And I'll plug that mic back in. If I knew where I'd put it. Oh, it's there. Sure that's in, yep. So we'll connect that across. So I'm not bothered how I've got it connected across. I want to see it change when we're going to transmit. It's a matter of trying to hold those wires in. I'll tell you what, we'll have it positive. Where I need an assistant to key that mic for me. So we've got 7.86. What I'll try and do is to, I'm now keying it. No, it's not making any difference. It's not going into transmit, let alone lighting up or whatever. So back to the circuit. In fact, I may as well use the transmit was the center pin number 2. So what I really need to do is to put the positive prod onto positive power, check that that gives us a voltage, it does, and then we need to put that on pin 2, which hopefully we can get to. Things aren't right. It's getting a permanent keying line, it seems. So I'll tell you what we'll do, we'll get a crocodile clip lead between chassis and our test prod. So now when I prod that, it's going to send it into transmit. And will the LED light up? I need the LED board. So I've got the LED board in such a way that I would see it if it lit up. No. We'll start looking at switching transistors, I think. And I wouldn't key up if the PA switch was faulty. Now there's an interesting thought. What I'm going to do, I'm going to switch the set off and I'm going to turn it between PA and CV about 20 times. And now we'll see whether it keys up. See, when you go into PA, you're not keying up the transmitter. All you're doing is making the mic connection, because the audio amplifier is on all the time. So don't think because it works in PA that the switching circuit works, because it doesn't necessarily prove that. So I wonder if we kind of go on to whatever wire. I'm just trying to work out which wire goes where. So from the white wire, oh well, I'll have a look at this and then we'll come back with a reason. Right, so we're back on with this, and I've changed the synthesizer chip. I managed to find an LC7136 in stock, and that's the last one of our LC7136s. It's possible I might be able to do that cheaper than the 1450 that the LC7137s are. I mean, they're all 30 years old, aren't they, or even 40. So straight away, without touching the VCO from the central position I left it, we have now got, that's not in the shot, 3.4 volts on receive, and I did just pop it into transmit, and it is transmitting. So I don't know why we're having a spate of faulty phase-lock loop chips. It's usually going to be static or being messed with, and this certainly hasn't been messed with. So they want you to do the 10.24 at pin 12, we don't do that. So we want to be on channel 40. And we want L116 on receive to be 2.5 volts. So it's a bit more, isn't it? Okay, we've done that. And now set the it's in transmit mode. What a twit. I'll kind of put that under my armpit. .5, and then on receive they want you to go to channel 1, and they want you to check that it is what? Around about 2 volts. So what's it transmitting on there? I think that's a bit low, you know. Oh well, it works out. So that's the VCO set. So I'll switch picture in picture on. And let's see what we are doing. So we're on channel 20. And the radio is, well, we're on high or low power. We're on high power. The radio is doing about 2.8 watts. We've just popped through the transmitter side. Just got my eye on the time. It's 7:20. I've got slow Morse practice with my radio ham friend Stuart. That's 3.1 watts. You can normally get, oh, we're on 12.4 volts, so I mean, will help if we bring the power up, won't it? I was doing that realistic walkie-talkie last. Okay, 3.6 watts, that's a bit nearer. Just check that's still at peak. So it's 107.98. Adjust 111, 112, 111. Yeah, it actually wants you to fiddle with the fixed coils. 115. 115 you drop down to get your power. So I don't like fiddling with airspace coils. It's a whisker away. It will do it. Yeah. They want you to set it for 3.8. We will not be doing that. It's set for 4. People want their money's worth, don't they? There we are. That's lovely. And it said counterclockwise. Just make sure I did that. No, I can't do that, or it'll be out of the coil. Check frequency. So we'll switch the camera over to the other display on the Marconi test set. So we want 2779125. It's 2779069, and as you'd expect, it's dropped with age being 40 years old. There we go. Now we can't do transmitter deviation because the mic doesn't work. What? Wallow. Absolutely nothing. Let's go back to the other. We'll sort that out later with a different mic. So we want RV103 to adjust that so that it actually does what the meter says. Yes, it says 5 and a bit, doesn't it? So that's a bit not right. So 103 is the one at the back. That's now reading the 4. Good. So Low power, I don't think that's adjustable on these, but we'll just check where it is. It's actually doing 520 milliwatts. This isn't that one, is it? Yes, it is. It is adjustable. So we're now at 400 milliwatts, which is correct. So 4 watts on high power, 0.4 on low power. Excellent. There's no mention of that here. So they now just want us to go. I've got looking at the time still. Sensitivity is excellent. We'll have time to make a start. On Maxon chassis, you do find that the detector coil can go out, which is the one down here. So we'll do that first. We're taking the bench light off, ready, and we'll just make sure that's peaked. I think we've made a fraction improvement there. Put the bench light back on, go over to the cyanide meter. So they want you to do 5, 6, 7, 8, 9. 5, 6, 7. So it's 5, 6, 7, 8, 9. 5, 6, 7, 8, 9 in that order. And then they say 105 for max. We start with that, whereas they want you to kind of begin with that, which is a bit bizarre. So we've got that kind of cyanide reading. At the moment, the sensitivity is 1.3 microvolts for 12 decibel cyanide. So hopefully we can bring it up a bit, but it's not too scary. Well, that's brought it up a fraction. And that's brought it up a fraction. Drop the attenuator again. That's brought it up a fraction. That's brought it up a mile. Let's check it again. Missed that one, didn't I, first time round? As it happens, it wasn't out. So the sensitivity is now 0.72 of a microvolt for 12 decibel cyanide. And it says it should be it's less than 1 microvolt for 20. Well, 1.6 microvolts for 20. I'll just see whether at that end we can just get an improvement, because sometimes you can. I don't think that's made any difference. Let's have a look. Oh, yeah, 1.4 microvolts for 20. So now our 12 dB is 0.72. Our 10 dB 0.68, and we can hear it to about 0.3. We're going to leave it there. I'll tell you what, I will do the S meter. It's reading S7. Some of these aren't adjustable. This has got the little preset dangling there, and that's now set to S9 for those 100 microvolts. Squelch. Let's see where the squelch is. I've put the squelch to full. It's not coming in. Just need to adjust that. Is that squelch? Yeah. So that's now coming in as 100 microvolts. Turn the squelch to minimum. Switch the signal generator to standby. Show you the attenuator controls. Set threshold. And switch on. Squelch is coming in about 0.28. Sorry, I'm totally lying. Squelch is coming in around about 0.88 microvolts and dropping out about 0.78. So that's fine. So apart from deviation, we're all done, and I'll see you tomorrow. So roll on the next day, and what I've done is to put the radio back together. We've changed the LED in the transmit light, which now works a treat. And what else have we done? That's interesting. How come the meter's reading right up there? Oh no, it's 4. So I made up another microphone. This is a brand new microphone, one of ours. So we've taken the plug back off his open circuit one, send him that back. He might get another insert in another scrap mic, but I think the inserts are the weak link apart from the case. Let's look at the deviation. So we'll pop that onto our main meter. We will. There we go. Let's select picture in picture. Wow, actually it looks spot on. Would you believe that? I'll go to the foot of our stairs. I haven't got any in a bungalow. It looks spot on. Wallow. I think we could just give it one fraction more. Wallow, 1, 2, wallow. Looks about right. So that's it, put back together. So basically, phase lock loop chip, change LED and a tune-up. As it was presented, it was doing 2.9 watts. And of course that hasn't altered with me changing the phase lock loop chip. So someone has not been enjoying all the power they were entitled to there. Receiver was a little bit out, but not so far that you'd notice. And although it was slightly down on frequency, it wasn't out of spec of frequency. So we'll pop that together, and the hope now, all that can go wrong now, is the speaker can be duffed, couldn't it? I expect he'll do something with those cases if he wants to. Right, the moment of truth. Unplug the extension speaker and see if it works on its own. Oh, it does. Right, we'll pop some case screws back on it, and I'll tell you what we'll do. We'll just put a couple in for now, just to hold it together, and I'll just do the on the air test. The capacitor arrived for that customer's Harrier CBHQ base station, so I just want to get that finished off. Now this customer with the Maxcom 4E has sent 2 Maxcom 4Es in, so we're not going to do his second one. We'll skip that and do another set. I know it doesn't sound fair that, you know, he's joined the queue and that, but I don't want to do 2 Maxcom 4Es with videos together. So we will go over to the next radio, and I think it's a Binatone 5-star. Let's hope it hasn't had the kiss of death with illegal channels fitted or something daft like that. Just make sure I'm plugged into the test gear, aren't I? I want the aerial. I'm waiting for Mr. Chippy to change the plug on one of the leads. So now I've got two leads that look the same with ordinary plugs rather than the compression ones we use on the bench. So switch picture in picture off. One niner, Roger. It's 5 to 10, you'd think they're out of bed by now. One nine, Roger. No, we're not going to get one. We'll just talk to it with our own walkie-talkie. I'll pop it to channel 20. I'd hate to annoy anybody on 19. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Okay, well we'll do a scratchy corner test before that goes back. That'll be Tuesday because Mr. Chippy's away seeing his lady friend this weekend. So thank you for watching the Maxcom 4E from, was it 1981? It's a 1982 February one. So it's nice to see a radio like that sorted. Not a cheap repair because those phase-lock loop chips certainly aren't that cheap, but a worthwhile repair considering the cost of new radios and how well, it's not that they're expensive, is it? I mean, there's new radios from £59, but the problem is when we've tested most of the new radios, they leave a lot to be desired. You seem to be getting features which you don't want, menus that you certainly don't want, and dreadful performance. So there we are.